Good evening. Today I would like to explain my conference paper title is Assessing the Role of Machine Learning Models in Groundwater Contaminant Monitoring and Management. And Welcome for this conference Adelaide 2004. And This is Dr. Asadi, and my colleagues are Dr. Alvin Lal and Professor Laureate Ravi Naidu. I have completed my PhD in Artificial Intelligence specialization and at Indian Institute of Information Technology, Allahabad. Currently, I am doing research on groundwater data, and thanks to my supervisors, Professor Laureate Ravi Naidu and Dr. Alvin Lal, for giving me this opportunity. The contents of my conference paper is introduction, objectives, methodology, results, discussion, future directions, conclusion, references. So coming to introduction about groundwater data, there are three things I would like to discuss in this introduction part. Groundwater, there are various types of groundwaters we can see in real-time environment. Surface water, drinking water, sea water, wastewater, etc. Groundwater is a subsurface water source may become contaminated and needs advanced monitoring and management for safety. So the importance of groundwater, it is a vital resource in everyday life. There are problems of groundwater like contamination, and solutions for groundwater advanced monitoring is required. Groundwater contamination poses significant environmental and public health challenges are there. So we are addressing these challenges with help of proposed techniques like machine and deep learning techniques. Monitoring and management involve using machine learning models to detect and predict groundwater contaminants by enhancing decision making for effective environmental protection. By using monitoring and management, use machine and deep learning models to detect groundwater contaminants for improving decision making for protection. The main objective of our conference paper is to assess the effectiveness of various machine learning models in groundwater contaminant monitoring and management. We have collected various case studies from all over the globe, from China, UK, USA, Bangladesh, India, Greece, etc. By using this machine learning and deep learning methods to address contamination issues by analyzing case studies and data and performing comparative analysis to manage groundwater pollutants. We are using a machine learning approach for investigating machine learning applications in solving contamination issues. We are examining 10 case studies, and we are finally come up with empirical data. And we have collected successfully nearly 20 to 30 papers, including BHP project and a few more projects with my supervisors Ravi Naidu and Dr. Alvin Lal. They have given various data sets, and we have collected suitable and closely related to our topic, assessing the role of machine learning models on groundwater monitoring and management. Here are the 10 case studies with columns like author details, title of the paper, country of location, challenges or issues, case studies, methods and algorithms, results and findings. So we have analyzed thoroughly 10 case studies, and we have identified various challenges and issues, and they have applied various machine and deep learning and statistical models, and finally they come up with very good output like increasing and overview of comparison, experimental, various results findings are analyzed. So, machine learning techniques in groundwater management are increasingly used to enhance the accuracy, efficiency, and effectiveness of monitoring and predicting groundwater contaminants. So, here we are performing tasks like contaminant transport modeling, pollution source identification, water quality assessment, groundwater quality modeling, and there are various key parameters in groundwater contamination assessment with machine learning. So, three variables are influencing parameters or variable affecting PFAS or groundwater contamination. Those are model accuracy, parameter optimization, source identification. In this model accuracy, it is critical for improving the precision of contamination predictions. Then parameter optimization highly influential, ensuring the reliability of results in contamination prediction. Source identification like a key in determining pollution origins and guiding effective management strategies. These are the key parameters are influencing in groundwater contamination. Then these are the final empirical and results analysis for our 10 case studies with the results highlights I have mentioned here. For example, in first case study they have applied AI/ML/DL approaches in contamination management, and finally they come up with a comprehensive review of AI/ML and DL potential in contamination management. Likewise, 10 case studies summary table we have arranged. Then out of 10 case studies, there are two important prominent case studies we have observed, and we are taking as a prime and first and foremost for implementation of our real-time applications. We are following these two case studies analogy and methodology. Like you and his team, they have published concept deep neural networks effectively model groundwater contaminant transport, greatly improving prediction accuracy and efficiency compared to traditional models. Coming to Mazumdar and his team, they have done tremendous work and optimized a machine learning model using XGBoost, enhancing prediction accuracy and reliability for groundwater contamination, emphasizing the importance of parameter optimization. So they have used machine learning approach. The final conclusion of our topic is to enhance groundwater contamination management by improving accuracy, modeling and optimization across various applications. And our research direction suggests enhancing machine and deep learning models, algorithms, incorporating real-time data and expanding their application across various environments for better groundwater management. And finally, we have used 10 case study references. With this one, I am closing my explanation. If you have any doubts, please ask me so that I can clarify.